So far, I've introduced you to a range of Swift and SwiftUI concepts. I've also given you a number of tips to help you write better code and help keep your code better organized. Here, I want to focus on that last part more clearly. I want to look at what's commonly called a software architecture, or in a more grandiose way, an architectural design pattern. Really, it's just a particular way of organizing your code. The pattern we're going to look at is called MVVM, which is an acronym for model, view, view model. That last part is just one word-ish, view model. And this is a terrifically bad name, and it's really, really confusing for folks learning it. But I'm afraid we're kind of stuck with it at this point. It's been around for years, so it is what it is. There is no single definition of what MVVM actually means, and you'll find all sorts of people arguing about it online, but that's fine. Here, we're going to keep it simple. We'll use MVVM as a way of getting some of our program state and our logic out of our SwiftUI view structs. We are, in effect, separating logic from layout. Now, we'll explore the definition a bit more as we go, but for now, let's start with the big stuff. Go ahead and press Command-N, make a new Swift file, and call this thing contentview-viewModel.swift. This thing has to have an import for mapkit, so we can use things like map regions and coordinates and similar. And we're going to use this thing to make a new class that manages our data, manipulating it on behalf of content-view. That's its job. So ultimately, our SwiftUI view struct has no idea what the data is, where it comes from, or how it works. We're going to start off with three trivial things, then build our way up from there. First, make a new class called viewModel, which conforms to the observable object protocol. So we can report back changes to any SwiftUI view watching us. Second, I want you to place this whole class inside an extension on content-view. So extension content-view, and then tab in the class like that. So now we're saying this isn't just any old view model for our whole program to use, it's really just for content-view. That's the content-view's view model. And later on in the challenges, it'll be your job to add a view model for edit view. So you can see how this technique works in other kinds of views too. The final small change I'd like you to make is to add a new attribute to this whole class, @main_actor. @main_actor. The main actor is responsible for running all user interface updates. And adding that attribute to our class means we want all the class in this code, anything you write in here, anytime it runs anything at all, unless we specifically ask for otherwise, to run on the main actor. And this is really important because this thing is responsible for making UI updates. That's its job, and those must happen. UI updates must happen on the main actor. In practice, it's not quite so easy, as you'll see in the next video. We'll come to that later on. Now, we've used the observable object protocol before with other classes, but we didn't give them the @main_actor attribute. So how come they worked? How come there wasn't a problem there? Well, behind the scenes, when we're inside a SwiftUI view and we use @stateObject or @observedObject or similar, Swift has silently inferred @main_actor for the class we were using. It understands, it knows both those property wrappers mean a SwiftUI view is relying on some external object to trigger UI updates. Because that's the job of stateObject. That's the job of observable object. That's their job, right? So it'll make sure that all UI work done through those state objects and observed objects happen on the main actor without us asking for it. However, that does not provide 100% safety. Nothing does, but doesn't even vaguely try and do it. Yes, whenever you have @stateObject, whatever, Swift will correctly infer main actor for that object. Whenever you use that inside your SwiftUI view, it'll be done in the main actor. Brilliant. But what if you call that class from somewhere else? A different class. Or a struct that's not a SwiftUI view, for example. Now the code can run anywhere. And so, that's not safe, because the code could be on a background task somewhere, try and publish updates to the UI, and bang, it'll be very, very unhappy. UI updates must happen on the main actor. And so by adding this main actor attribute to our class right up here, we're taking a belts and braces approach. We're saying, to Swift that every part of this class should run on the main actor. So it's safe to update the UI more or less no matter where it's used. And you'll see it's more complex in the next video, but for now it's good enough. If you're not sure, if you're thinking, oh, this is hard, well, I don't understand this at all. Every time you have a class that conforms to observable object, add main actor. Just do it. There's no reason not to. It should always be on the main actor. Okay, now we have this class in place. We get to choose which parts of the state from our content view should be moved into the view model. Now, some folks would say all of it. Get all state out of the view and into the view model. Other folks would be more selective. That's okay. Again, there is no single definition of what MVVM looks like. Everyone argues and disagrees. That's fine. I'm going to provide you with the tools and knowledge to experiment yourself. Let's start with the easy stuff. Move all three of these @state properties out of content view and into the view model. Now, we don't want to use @state private var anymore because these aren't SwiftUI state values anymore. They're designed to be published externally. So they aren't private either. They're public to be published to other views. So remove @state private and instead say @published. And the same for locations. And the same for selected place. Get rid of @state private and just do @published var instead. Now that's going to break all sorts of code back in content view because we need a way to reference those values. We haven't got local state anymore. So instead we'll say @state object private var view model is our view model. And that will automatically refer to the class inside our extension, the local view model. Now, remember, @state object will automatically know, aha, this means every time I call view model inside my SwiftUI view, it will be on the main actor. It'll infer that main actor thing for us. But belt and braces, we've said a main actor as well, just to make really, really sure, or as sure as we can. Anyway, now it's going to still break code because we reference things like map region or locations, things that were local before but now belong to our view model. So the fix here is to add view model dot in all these places. Refer to view model dot map region, view model dot locations, view model dot selected place. Oops, like that. View model dot locations, view model selected place, view model locations, view model locations, like that. Hopefully that'll build our code. Now I missed two up here, whoops. There's one here and one here. Okay. So once you've added view model dot everywhere, there's a good chance you're wondering, how has this actually helped? Yes, my code compiles, but all we've done is move code from A to B. How's that better? Yes, we have just moved code from A to B, but, critically, as you progress in your skills and go further in your Swift career, you'll realize that having this functionality, properties and methods and more, in a separate class like this one, makes it much easier to write tests for your code. Because testing SwiftUI views is complex. You'll launch Simulator and do virtual taps around the screen. This is a class. We just make one of these and just poke around it directly and see what comes out. Call functions on it directly. It's fine to do. So it actually makes it much easier to write tests for having a separate view model like this. Now, views work best when they handle presentation of data. Show a map, show a circle, show a VStack, whatever. But manipulation of data is a great candidate to go into your view model. Anywhere you want to change data. Now, if you look through your content view code, you might notice, if you look carefully, two places where our view does more work than it ought to, where it's trying to change data. And there's one here, we're modifying the view model selected place. And there's one down here as well. And even a third one actually, down here. This thing. So there are three places we're modifying data. Now, of those, this first one's fine. There's not much we can do with that really. We've got a location, what do you want to do? Selected place. But this is digging around in the map region, then modifying the array, And this is doing the same thing with the array. We're digging through to find stuff, then modifying it directly. It's really not very nice. Now, reading data from our view model is great. Even if it's via properties exposed with @published. We have our map region or our locations here. That's all honestly fine. Reading's fine. But writing it like down here with logic, this kind of code down here or down here, this is not great. Because the whole point of exercise here is to separate our logic from our layout. We've got to get any logic we can out here. And you can find these two places immediately if you clamp down on writing to the view model data. So we could say in our view model that this locations array is private set, meaning you can read all you want to, reading's fine, but only the class itself can now write locations. And so, in this file, it just disappeared entirely. Thanks, Xcode. Cool. Xcode's angry with me. Let's try that again, Xcode. There we go. Cool. In here now, it'll be angry at us. It's saying, well, you can't modify the array directly. That's not allowed. And that's changes back to view model dot, and then view model dot. So you can't modify the array directly down here and down here. It's not allowed. You can't do that. And it's giving us a big hint. This kind of code, this kind of logic needs to be somewhere else. And so we can start by taking out this first piece of code here to make a location and put it into the array. Command X that to your clipboard. Then go over to your view model and add a new method. We'll say func add location. And let's paste that on in. Now you can remove the view model here and here and here. Otherwise, it's good. That's the method. And back in our view, we can just say view model.add location, which is much, much nicer. The second problematic code is down here, where we're digging around the array to try and find a particular place, then changing the array and causing a refresh. The whole if let index block here, again, command X that to your clipboard, and then back in the view model, add another new method for this. We'll say func update location here. And what we're going to say is paste that in for a start, that's fine. But first we're going to find out what will actually changing. What should this old place value be? So we'll say guard let selected place be selected place else return, and then put it on one line because I love it on one line, like that. If we have that, we'll put selected place here, and then down here will be our new location, like that. Now, obviously, remove view model from here and here, so code actually compiles. It works much better. And now, inside our content view, we'll use that method instead. So we have the new location coming in here. We'll do view model dot update. Location is new location. Boom. At this point, the view model has taken over all aspects of content view to handle data manipulation, which is great. The view here is to provide and present data, and the view model is there to manage data. Now, in practice, a split honestly isn't always that clean. In fact, it's rarely that clean, despite what you might hear online. And once again, that's okay. Once you move on to more advanced projects, you'll usually find that one size fits all approach usually fits nobody. And so we just do our best with what we have. Anyway, in this case, we now have a view model here that supports our data being handled correctly. So we can upgrade this thing to handle loading and saving transparently without our main content view having to care about it. This is going to look inside documents directory to find a particular file, decode it or encode it for saving it using JSON encoder or JSON decoder, and then put it into our locations array. Now, previously I showed you how to find an app's documents directory using File Manager with a reusable function. Here, though, we're going to package up on an extension on File Manager, which I think makes it easier access for other kinds of projects. So press Command N and a new Swift file called File Manager -documents directory, and give it this code. extension file manager, static var documents directory is a URL. You get all the paths from file manager.default.urls for .documents directory in user domain mask and return path 0, like that. And now we can make a URL to a file in our documents directory wherever we want. However, I don't want to do that when we're both loading and saving data, because it means if you want to change your save location, you've got to change both places. A better idea is to modify your concept view model here to have a constant property here that'll store your saved location, so it knows where to read and write data from in one place. We can say, let save path be file manager .documents directory .appending path component saved places. And now we can use that when reading and writing files with the same file in both places. So first things first, we'll add a new initializer that will load our data from disk. We'll say init do let data is try data contents of our save path. Locations is try JSON decoder .decode array of location.self from our data. And if that fails, then locations will be just an empty array. Like that. That's loading stuff. As for saving, previously I showed you how to save things with a string, writing a string to disk. But the data version, using data rather than string, is actually even better. Because it lets us do something quite amazing with one line of code. We can ask iOS to ensure the file is written with encryption, so that it can only be read once the user has unlocked their device. This is in addition to requesting atomic writes. iOS does almost all the work for us. So we'll say func save do, scroll down, let data equals try JSON encoder this time, .encode our locations, and then try that data .write to with options. The URL is our save path. Our options will be .atomic write and .complete file protection. Give me both those things, please. And if that fails, we'll catch print unable to save data, like that. Honestly, it's quite remarkable. All it takes to ensure the file is stored with strong encryption is to add .complete file protection to our options. That's it. Now, using this approach here, using JSON decoder and our documents directory, means we can write any amount of data in any number of files. Someone asked in a comment to a previous video, can I write sounds? Yeah, you can write sounds, write movies, write text files, write whatever you want to. Just be wary of taking up too much space because the users might complain. Anyway, that's it. And it's much more flexible than user defaults, because it'll load when we're ready as opposed to when the app launches straight away. It's much, much nicer. Now, before I go to this step, make a handful of small changes to our view model so it uses the new initializer and new save. First up, the initializer will make sure locations is either the array of our saved data or an empty array. And so up here, our published locations can now just be an uninitialized array of location. It'll have a value in the initializer no matter what. That's the first step. And second, we've got to call our save method after we add a new location or after updating an existing location. So down here in add location, we'll say save, and we update. Down here, we'll say save. With that, go ahead and run the app now, because hopefully we should find, I think I've tried before, being well, we can load and save data. Let's see what I've managed to do. I'll go to London, add a pin there, and I'll call this thing Central London. Then press save, and we'll add one more up here, somewhere approximately here, approximately there. I'm going to say this is about Fort William, like that. So two values, and they're saved immediately. There's no need to delay that we had with user defaults. If I go ahead and run the app again, all being well, it will have saved our data. And there we go. Central London and Fort William. Now I know this took quite a bit of code to get the MVVM, get the codable stuff working, but the end result is that we have loading and saving done really well, because all the logic is outside our view. This thing has no idea what's going on. As you carry on learning in the future, getting better and better at Swift, you'll realize it becomes so much easier to write tests for a class like this than trying to use a SwiftUI view to test. Second, we're making iOS encrypt our data so that we're protecting users' privacy. It cannot be read or written until the iOS user unlocks their device. But the load and save is completely transparent as well. The view has no idea what's happening here. We just call init and save at the right time, and it just does everything for us. It's really, really nice. Of course, our app is not truly secure yet. We've ensured our data is being saved with encryption, but there's nothing stopping someone else from just reading data afterwards, from launching the app and having a look for themselves.